Hello everyone, good morning. This is Mr.DHAKSHUNHAAMOORTHY, Assistant Professor in the Department of Artificial Intelligence and Machine Learning. I am handling subject 22 CS 302 Computer Organization and Architecture for the class second year 4th semester. Today's topic is Direct Memory Access DMA. Direct memory access DMA transfers the block of data between the memory and the peripheral device of the system without participation of the processor. Here the processor is interconnected in between the IO device and the memory. With the help of DMA controller, this connectivity between IO device and connectivity between processor to main memory is temporarily removed such a way that system bus is directly connected between IO and memory. We will see the concept. Direct memory access DMA basically stands for direct memory access. It is the process which enables the data transfer between memory and the IO or input output device without need of, or you can say without the involvement of CPU during data transfer. Working of DMA. The following list of points will describe briefly about DMA and its working as follows. In this diagram, we can see the sequence of operation denoted by numbers 1 to 6. Those 6 steps only we are going to discuss. Here number 1, IO device is giving request to DMAC. I want to transfer data to the memory. Then that request is accepted by DMAC controller and it is sending hold signal to the CPU. CPU is giving two information to DMAC. One is starting address, another one is data count, how much data you want to transfer, those information to the DMAC, and also hold acknowledgement signal to the DMAC. After getting hold acknowledgement from CPU, DMAC sending DMA acknowledgement signal to the IO device, whichever DMA request given. After that, IO device is getting the direct access from memory to IO, so that the data is transferred from IO device to memory or memory to IO device. But during this process, CPU does not involve the operations of the memory to IO data transfer, and it is in blocked state. During this tenor, it can perform whatever the operations assigned to CPU, but it is not monitoring the operations of data transfer between memory and IO. So, we will see one by one. For DMA, you basically need a hardware called DMAC, Direct Memory Access Controller, which will help in the throughout process of data transfer between memory and IO device directly. First, what happens is IO device sends DMA request to the DMA controller, then further DMAC device sends HOLD signal, hold signal to the CPU, by which it asks the CPU for several information which are needed while transferring data. CPU then shares two basic information with DMAC before data transfer, which are starting address, that is memory address starting from where the data transfer should be performed, and data count, number of bytes or words to be transferred. CPU then sends hold acknowledgement HLD ACK back to DMAC, illustrating that now DMAC can successfully pass on the information. Then further DMAC shares DMA acknowledgement to the IO device, which would eventually let IO device to access or transfer data from memory in a direct and efficient manner. This is how the working principles of DMA. Now the modes of DMA transfer. Now after getting some brief idea about DMA and its working, it is the time to analyze modes of DMA transfer. During DMA transfer, CPU can perform only those operations in which it does not require access of system bus, which means mostly CPU will be in blocked state. For how much time CPU remains in blocked state, or we can say for how much time CPU will give the control of DMAC of system buses, will actually depends upon the following modes of DMA transfer. After that, CPU will take back the control of system buses from DMAC. DMA modes of operation, in which first mode is burst mode, or in this mode entire data or burst of block containing data is transferred before CPU take control of buses back from the DMAC. This is the quickest mode of data transfer, since at once a huge amount of data is being transferred. Since at once only the huge amount of data is being transferred, so time will be saved in huge amount. Advantages: fast mode of DMA transfer. Disadvantage is less user friendly, because during the DMA transfer CPU will be blocked. The percentage of time CPU remains blocked is, we can calculate. Let time taken to prepare the data be Tx and time taken to transfer the data is Ty. Then the percentage of the time CPU remains blocked due to the DMA is as follows: Ty by Tx plus Ty into 100%. Mode 2, cycle stealing mode. Slow IO device will take some time to prepare data, and within that time CPU keeps control of the buses. Once the data or word is ready, CPU give back control of system bus to DMAC for one cycle, in which the prepared word is transferred to the memory. As compared to bus mode, this mode is little bit slowest, since it requires little bit of time, which is actually consumed by IO while preparing the data. Advantage is most efficient way for data transfer, but rate of DMA transfer will be less. CPU won't be blocked the entire time. The percentage of time CPU remains blocked, let the time taken to prepare data be Tx, time taken to transfer the data be Ty. Then the percentage of time CPU remains blocked due to the DMA is as follows: Ty by Tx into 100. Mode 3, interleaving mode. Whenever